Hello everyone, hello and welcome. This is Aurora with the Central Coast Astronomical Society. Are you guys excited about tonight's conjunction? Me too. So we've actually put together something really special, and I wanted just to say hello and welcome to everyone. This is a really cool event just because I feel like it really allows people to understand like where we are in the universe and really see it for yourself, or at least the solar system. So we have a fun event planned for you tonight. We won't be on for very long, maybe 20 or 30 minutes. And one of the first things I'd like you to do is type right now in the comments box. Let us know where you are in the country, or in the world. So if you're outside the United States, go ahead and let us know in the comments what part of the world that you are in. So let us know your country, and just let us know where you're connecting from. That would be really helpful. We actually have a telescope piped in, and you're actually going to see the conjunction. We're going to answer your questions. We have a lot going on right now, so it's super, super fun. I know there's a lot of observatories that are also doing live streams, and so this is just a little local group, Central Coast Astronomical Society. We have been doing free stargazing since March online. It's been a virtual stargazing event. We just did one last night. If you'd like to see that, you can go to our website, which is www.centralcoastastronomy.org. There's a little link right there at the bottom, and you can still watch that. So our goal is for you to get outside and look up and know what you're looking at and know where to find it. So we do a few different constellations each time. So we did that last night with Kent. Tonight, Brian has set up his special observing, has set up his telescope and his special observing stuff he's going to share with you. He's kind of fiddling with things right now, but I wanted to, he'll be available in just a minute here. In fact, I can zoom over. You can kind of see what he's seeing right now through a telescope. And I don't know if you can see it on your screen, but there is a big bright dot, and there's another dot. This dot is a different color than this one. This one's also, there we go, thanks Brian. This one's also a different, it's not round. So before we get started, we're actually going to cover a little bit tonight. I did have a number of questions that have been coming in. I wanted to handle those first. So first of all, welcome. My name's Aurora with the Central Coast Astronomical Society. So this conjunction of Jupiter and Saturn, you can actually see it all month long, not just tonight. Tonight is where they're just the closest as approach, closest they're going to be, and then they're going to start to spread out. So kind of giving you a little bit of background. So this conjunction happens about once every 20 years. So you may be thinking, well, what's all the hype about right now? So people are really excited because typically when this conjunction happens, so first off, Jupiter makes a circle around the sun once every 12 years. Saturn is a little bit further and it's going slower. So it goes around the sun once every 30 years. So if you've ever watched runners on a racetrack, or if you've ever watched, like a NASCAR raceway event, right? So you've got these race cars on the track and they're going zoom, zoom, and they're going around, around, around. So it takes a while from your perspective, to see one catch up to the other. So what we see in the night sky, what we've been looking at pretty much for months, is we've been seeing Jupiter catching up with Saturn. So it would be like a slower car, or a car that's moving faster, kind of catching up with like a slower car on the outside track. And so from our perspective, it looks like these two planets are getting really, really, really close. But in reality, it's just our perspective that's happening. So they're not going to merge. They're not going to gravitationally interact and yank on each other more than they normally do. It's just from our perspective, those two objects are going to be just passing really close to each other. Now, why is this so important? Well, it's for a couple of reasons. There isn't any real science missions that are making use of this conjunction. They can do that. They can use, for example, the light that's being reflected off of Saturn and use it to backlight the atmosphere of Jupiter, but they're not doing that. They're just enjoying the conjunction this time. There's no special mission for this one. What's really cool about this is that because of the way that the planets aren't all perfectly in a flat plane. So that means that, well, sometimes they line up and sometimes they're a little bit further when they pass each other, sometimes they're a little closer when they pass. So every 400 years, this conjunction happens where they're about a tenth of a degree. So they're super close. They're closer than the diameter of the moon. So you can think of a degree as like 2 moon diameters. So this time they're like a tenth of a degree, which means they're really, really close. So in an eyepiece, if you were to look at this through a telescope, you could actually see both Saturn and Jupiter in the same view, which was really good for photography. Okay, so so tonight they're actually going to be, Brian, is it 1/10 or a 20th of a degree apart? I forget.
That's a good question. I have so many screens going. I don't have my fact
No,
list
that's
up.
okay. That's all right. Well, I'll look it up. So right now, what you can do tonight is you're going to go outside at sunset, which on the west coast is happening now. You're going to go outside. You're going to look southwest, and as long as it's not rainy, as long as it's not cloudy, you'll be able to see this. Even if you're in a really bright city and you've got like bright street, like light pollution everywhere, street lights, you can still see this. From anywhere in the world, you can see this happening, which is really cool. And not just tonight, but you can see it tomorrow and the next day and the next. And slowly over time, those two planets are going to appear to be further and further apart. So tonight is just the part where they're actually coming close together. And so when you go out, you're going to look southwest, and you'll have about an hour before they dip below the horizon. And so you'll be able to look at it. You don't need a telescope. You don't need fancy binoculars. You can certainly, absolutely. People are taking great photographs with their cell phones. They're taking great photographs just with their small cameras. So you don't need anything really special because these are really bright objects. And so that's something else you can look forward to too. Okay, a couple of other questions. Was this seen by Galileo? Okay, so no, it was never recorded with Galileo's notes. And in fact, I did print out a few of the pages from Galileo's notes in here in his notebook. And he actually does show Jupiter and the moons that he observed down here in the lower area. And he also has pictures that he drew. He didn't know what was going on with Saturn. He knew it was oval, like if you look at Brian's picture right now through his telescope, it's kind of an oval shape. It doesn't look round, and it's fainter and it's smaller. So Galileo was the first person to actually point the telescope at the sky. I mean, there were telescopes around before that, but just nobody thought to look up with them. And so, so right in that time period, this conjunction happened very shortly after this really, really special one that we're talking about tonight. However, if you've ever noticed, when you go outside, sometimes there's a moon and sometimes there's not. Have you ever gone outside during the daytime? And I remember the first time I saw the moon during the daytime, I'm like, what is that doing there? The truth is the moon is up during the day sometimes, and sometimes during the night, and sometimes both, and sometimes none. So that happens with conjunctions too. So 400 years ago, this conjunction happened, but it's really, really possible that nobody knew about it because it happened during the daytime. So the last time that this one was seen worldwide by people across the planet was actually in the year 1226. And so that's the last time this special conjunction happened at night. And so that's why there's no notes from Galileo about this particular conjunction that we're talking about. And let's see, other questions we're getting. How are conjunctions new? No, people have known about conjunctions for as long as they've noticed that some of the stars started to move versus some of them not. So Ptolemy back in 100 CE, 100 to 170, right there, he was able to predict the motions of the planets. He was one of the first that we know about. Kepler in 1570s to 1630s, he was one of the first to really understand the nature of the orbits of the planets. So he also knew about conjunctions. So these conjunctions aren't new. They're just, we've known about them for a long time. Other questions? Let me answer. I'm just going to answer like one or two more, and then we're going to go over to Brian. So Brian, you almost ready for us?
I'm ready. I'm ready anytime.
Oh, you are ready. You are ready. Okay, let me answer this last one. Will Jupiter and Saturn overlap, and will it become a big bright star? Okay, no. So what's going to happen is you'll see them go outside tonight and just go look southwest. It should be there for you. And you'll see them, you can still, even with your naked eye, see two bright dots. You won't actually see the rings of Saturn with your eyes. You'll need like a telescope or a pair of binoculars to be able to tell, excuse me, that it's not perfectly round. It's more like an egg. And so once you, so let's see. So you'll actually be able to see the two dots. They won't actually be perfectly on top of each other. They're going to come close, and then they're going to be further apart. Okay, Brian, you ready? You ready?
I'm ready. Yes.
All right. So now it's your turn, Brian. I think I
All
answered
right.
a lot of the major
yes,
questions.
definitely.
So hi, this is Aurora with the Central Coast Astronomical Society, and Brian is with me with the telescope in his backyard, and he is going to talk to you about what he's seen. Are you ready, Brian?
I'm ready.
All right, here we go.
All right. So here we have a view of Jupiter and Saturn, and I'm going to fiddle with the exposure to show you the best detail I can. If we notice up here, the one on the top would be Jupiter, and then down here we have Saturn. And because of their difference in brightness, it makes it a little bit interesting to show them both in detail live. So I'm going to fiddle with the exposure so that we can see a little more detail. Let me show you a little bit more of the ring with rings with Saturn. What I'm going to actually do is bring up the zoom. Let's see if I can still see it in here. Yeah, that's 400 times zoom from the natural size of my camera. And so I'm going to bring up the gain just a little bit, and we'll start to get you a little more detail. And I need to watch out that I don't blow out the picture. Now, let's talk about something for a moment. You notice how they're jiggly, and planets shouldn't be jiggly, but we like to breathe, and it is our atmosphere that actually bends light as the light travels through it that's coming reflected off of these planets. And so with this light coming off as it travels through the air, especially as the earth is cooling as it gets darker, then those heat waves actually change the light and bend it. And that's what you're seeing is the bent light coming through here. And the lower it is on the horizon, the more jiggly the images become. And so, of course, these, as you know, are very low right now. So that's part of what we're dealing with. So let's see. I'm going to back out the zoom just a little bit to 300 times. And I'm going to bring up the power a little bit more. I'm sorry, the gain. And I want to see if I could show you any of the Galilean moons. And so sure enough, now what happens is the more you add gain, the more noise is introduced by the camera. And so I can't really get the moons very well for Jupiter, but that's okay. I highly encourage you, if you're able to even look at with any kind of binoculars, then take a look and you'll be able to see at least the Galilean moons, the 4 largest moons for Jupiter, and you might be able to see Titan. Aurora, with my 10-inch telescope last night, I was
Yes.
able to see Titan
Wow,
easily.
that's awesome.
It
I'm
was a
showing
nice
right now,
clear
Brian,
night.
I don't know if you can see, I'm showing an
Yes.
image that was taken a week ago by one of our members, and he actually labeled which moons were which. So this
Yeah,
was
that's
taken,
a very
yeah, this
useful
is the one
image.
from Nico. So this is a week ago. And so this conjunction has been happening all month, and it's going to continue to happen. And it's just tonight, it's as close as possible. These planets are not physically colliding. They are not going to smack into each other. It's just a perspective thing. And so it's looking like one object is moving behind another. And so this is what he's trying to show you here. And he said he just saw Titan, which is that dot right there. That's the largest moon of Saturn. Okay, go ahead.
Right,
Keep going, Brian.
absolutely. No problem. So by the way, I'm using a just about a 4.5-inch refractor telescope for this. And you'll notice that many people will be able to show much more detailed images of the planets. But I like this telescope because it gives me a nice wide field of view. Just to give you a hint of what this would look like, if I was to pull this out to the lowest power magnification in my program, this is what we'd see. We could see just barely Jupiter. That's it. So I'm really amplifying this picture, or I guess I should say zooming in on this picture so that we can see it much better. So um, what I thought we could do, Aurora, is I was going to bring up the diagram of the solar system to give
Okay.
everyone a little better idea
Oh, yes,
of how this
yes.
looks. And then what we'll do is we'll definitely come back and revisit this. It's still a little bit of sunlight remaining, a little bit of glow. And so once we get even darker, then I can pull out probably a little bit more detail.
Awesome. And we've got a lot of people asking about your equipment as well. So why
Yes.
don't you, we'll save that for the
Do
end.
you,
So
okay,
again,
certainly.
this is Aurora and Brian from the Central Coast Astronomy Club. It's just, we just love sharing astronomy with the community. If you have specific questions, I'll do my best to answer them. If any of Central Coast Astronomy astronomers are on right now, I know they are so busy answering everybody's questions in the chat. So thank you, all of you who are helping out so much. We have 1,300 people watching right now, Brian. Are you ready?
Very exciting. Yes, I'm ready.
All right, let's see it.
So this is a program called NASA Eyes Visualization. And by the way, I highly encourage you to make your computer full screen as we show this diagram. So we're looking as if we went straight north from the Earth. We're able to fly above our solar system. This is the view looking all the way out to Saturn. And just to show you, we're gonna go a little bit higher, so to speak. We can see Uranus, and then the orbit for Neptune, and then even Pluto way out here. By the way, if you're wondering where Voyager 2 is, way out here, but I don't want to get myself off topic, so I won't start talking about how wonderful the
That would
Voyagers
be another
are.
fun discussion.
That would. So I'm going to lower our altitude, so to speak, so that Jupiter and Saturn are just here within view. So we can see here, of course, here's the inner solar system. I'm going to pull in a little bit so you can see the blue circle, or technically the blue ellipse, is our orbit for Earth. And then next planet out would be Mars. And then as we go a little bit higher here, here's Jupiter and then Saturn. So from this view, we could start to notice, well, if I look past the sun, because remember the sun just set, and we can even see that from this view of the solar system. The sun just set, and then here's Jupiter, and then here's Saturn. But what I can do to give you a better idea of how this works is we can change our perspective here. And I'm going to give it a little bit of angle just because of all the titles we see for everything. So notice here now, here's Earth, and you can draw a straight line just about to Jupiter and Saturn. So that shows that perspective that we are having right now from Earth. And so that's what I wanted to show. I'm hoping that gives everyone a little bit more of an idea of why it is that we're seeing this. Oh, I know what I wanted to do. Let's go back so we're looking overhead, so to speak, and let's see what will happen. I'm going to go back in time first. What had things been like over the past month? Well, let's back up, and this is fun. We can control time. So here we are. This is where Jupiter and Saturn were back in February. Notice not that far different. They're much farther out from the sun, so it takes them, their year is much longer. But anyways, I'm going to back up. Let's go ahead and go back to 2017. Here's Earth, and then here's Jupiter down here on the lower part of the screen, and then Saturn off to the right. And then we're going to go forward in time. I'm on camera, by the way, just so you know. Sorry, I just had other people here with me, so I wanted to make sure they knew they'd be visible worldwide. So here we are. Let's come back up. You know what? I could do this easier. I'm going to click now. So here we are back on where we are today, Earth, Jupiter, and Saturn. And let's just notice what's going to happen. Aurora, you had mentioned how they're going to be nice and close to each other for a while still. It's not like this is the only night to see them. Right. Let's just advance just a little bit faster. So I'm right. Amplifying time, and I'm going to do it fast enough so where we can see the planets actually moving. So here, even into January, notice that Jupiter and Saturn still are not that far apart if we look at them edgewise. So you can still see them, and what will happen then, they're going to start to move farther apart as time goes on. Let's take a look for our last little view at December. Went a little too far.
So this is a program that people can download, right? If they
absolutely.
Like to.
So you notice right up the good question on the screen, it has it up in the corner. So it's NASA Eyes on the Solar System. So if you Google NASA Eyes, you can download this to your computer. Faster the computer, the better, for sure. And then you can play around with all kinds of different things. This program actually has a lot of tours. If you go up to the top right corner, it has some automated tours where they will take you with a narrator around different parts of the solar system, or some of the exoplanets also. And the exoplanets are, of course, artist renditions, as unfortunately we're not able to clearly image exoplanets yet, but it's a really fun program and very useful for things like this.
Awesome,
So
awesome.
yeah,
Okay, great.
so I'm
Did
going to
you want to
switch back
show any
over.
more on the? Do you want to? People are asking for the real image.
Yes, I think that's a very good request since that's what everyone is really here for.
Okay, great. So
Definitely.
again, if you've just joined us, this is Aurora and Brian with the Central Coast Astronomy Club. We're just a little local club that loves to share the skies with the community. And so Brian has set up his backyard telescope, and I'm answering questions that are coming in. You guys are asking lots of great questions, and also we have astronomers that are answering the questions in the chat. So thank you. So go ahead, Brian. Let's see. Let's take a look at your telescope.
All right, excellent. So this is the live view again, and so I'm adjusting the tracking just a little bit so that before I increase the percentage for the magnification, I want to make sure that I'm as centered in the view as possible. So I'm just giving a little tweak here. I think that'll be good. And so now that we have them centered, let me beef up the zoom. So we'll go up to 250%. And here's the live view again. So I'm going to increase the gain just a little bit. We'll go up to 325 for the gain. And yeah, I think I'll actually go a little bit higher.
There we go.
So
And you can see Saturn is going to be fainter over here.
yes.
And Jupiter is going to be the brighter one over here. And
yeah, again.
And
oh,
if
go ahead.
Brian
I'm sorry.
adjusts his controls, you'll be able to see the moons pop out on at least on Jupiter.
Yes. And what I could do too is because Jupiter is so bright, I actually have a cover over part of my telescope. So less light is coming in. And what we could do when we're just before these planets go below my fence here, I can take off that cover and then that'll give me a better odds of getting Jupiter's moons also. So I'm going to tweak my gain or my exposure here. Now, you may notice that these are actually just 5 millisecond exposures. In case you're wondering, a millisecond, there's 1,000 milliseconds in 1 second. And so this is only 4 millisecond exposure, and I'm able to pick this up. And whenever we do this photography live, it's a combination of the exposure time. In other words, how long is the camera looking for each image, and then the gain, how much is it amplifying it? And when we start taking pictures where we have stars in the field, we can actually stack more than one picture together and combine the exposure. But I don't have any bright stars I can get in this field, so I'm not able to stack this. When we start share some deep sky objects at our next public event, then we'll definitely be able to give you a lot more detail than this.
Yeah, one of the questions people are saying is, what happened to all the stars? Why am I only seeing
Yes,
planets?
very good question. In fact, this is a question that comes up when people look at a lot of pictures from the Apollo missions where they're on the moon and you can see the astronauts and their lander great, and you look in the background and there are no stars. That's because we have to adjust that exposure time and the gain or sensitivity. I have my camera set for the brightness of the 2 planets, Jupiter and Saturn. And because the gain is set for the planets, which are so much brighter, the stars cannot be seen. And if I start to bump up my gain, then we can start to see some stars, but you're also getting noise. Notice how in fact, I'll bump it up so that you can see it over the stream. That's at maximum gain. And it's starting to look like your television set back when we used antenna, looking at snow. That's all noise coming from the different sensors on my chip. And so part of the adventure is there aren't any really bright stars around where Jupiter and Saturn are at the moment. If we happen to have something brighter like Vega, let's say or any of the stars in the summer triangle, I could get them into this image, but there's just too much difference in brightness. So that's why. All right,
Nice.
let me get this back so where it's a better picture.
People are asking about your telescope. What kind of telescope are you using and camera?
Do you happen to have that picture handy?
Oh, I'm on my emergency computer. For
Your
those of you who
computer.
follow us regularly, they're like, hey, that's not Aurora's office. This is my backup computer.
Yeah.
Basically, my husband's computer.
Gotcha. All right, I'll bring it up since you have my share off.
So yeah, if you have it, and I can share your image.
All right, awesome. Well,
Um,
I can share. I'll go ahead and share it from here.
okay, great. Let me flip back over to you.
Let's see. Yeah. So what I'm using is a 120 millimeter refractor, which is from Orion telescopes. And so it's just about between 4 and 5 inches in size. Refractor describes the fact that light's entering from, let me see, I need to see what you're seeing. Okay. Light enters here from the front where it says the word Orion, and then lenses refract or bend the light until they enter the sensor down here. So this red guy down here on the other end, that is the camera. This is a ZWO ASI camera, and it's the ASI 2600 MC Pro. And you notice how it has fins on it. When this camera gets to working, it actually has to keep itself cool to get the best quality image. So it actually has a built-in fan and then cooling fins to keep it going. So then when I'm doing more deep sky astronomy, I actually have a camera that I hook up to my finder scope. This little one is same company, ZWO ASI 120. This one's black and white, but it's really good for getting an image of stars. And then we can actually use this mount, which is the Celestron Advanced AVX. You can hook up what's called an auto guider. So with a little bit of settings, you can have a camera that takes a look at a set of stars and it will keep your telescope pointed on that set of stars. When you take pictures of really, really faint objects, you need to keep exposures much longer. And so this kind of a setup with an extra guide camera helps you do that.
Nice. Thank you, Brian.
All
That's
right, you're welcome.
awesome. Okay, we've got a number of questions. Do you want me to take some, or do you want to talk a little bit more about what you've got?
Well, maybe we'll just keep the live view up and we can just start
Okay,
to address
great.
some of the
Here, let me,
questions as
so
we're
people
going.
can see what it really looks like rather than just
Yeah.
me. There we go.
Yeah. Cool. And I'll just kind of be fiddling with the exposure as we go.
Okay, great, great. Okay, so we have a number of people that want to do astrophotography now.
Yes, no surprise.
So this is Aurora. Here, let me show you. let me talk to you in person for a second. This is Aurora with the Central Coast Astronomical Society. We are sharing the conjunction with you tonight, and you can see it from anywhere you are in the world. And this is not the only night. It just happens to be the night where they are going to be the closest little dots, the two little dots that are coming together, Jupiter and Saturn. And then you're going to see one overtake the other, Jupiter overtaking Saturn, and then you'll be able to see it for several more weeks. So this is a conjunction. One of the questions we're getting a lot of, Brian, right now is how is a conjunction different from an eclipse? Do you want me to answer that, or would you like to go for it?
Sure, I can take care of that one.
Great, go for
it. So with an eclipse, and then you can tell me if I'm right. With an eclipse, what's happening is one object is blocking another, and we use that in a term most commonly between relations with the sun, moon, and Earth. And so, for instance, if we have a solar eclipse, then the moon is going between the Earth and the sun, and that allows the sun to be blocked so we could see just the outer atmosphere of the sun. And with a conjunction, the objects are close to each other from our view in the sky, but they are not necessarily or aren't really blocking each other. If you have two objects out past our solar system, for instance, or an object in our solar system that blocks something farther out, like a star, that's called an occultation. So we really introduced three terms. We have an eclipse, a conjunction, and an occultation. So we're looking at, between Jupiter and Saturn, a conjunction tonight. And in 2024, by the way, across a very big strip of the United States, we'll have another wonderful total solar eclipse, which everyone should start setting their calendars for. Occultations actually happen quite often. In fact, the moon commonly occults various different stars, and scientists can learn a lot when that happens. How's that?
That was perfect. That was
Great.
perfect. Okay, so one of the questions that's coming in, one of the requests, Brian, I didn't even think of this, but people are wondering, can you make your screen full screen? Because the light from the sidebar
makes it difficult to see.
Is making it so it's hard to see. Uh-oh, and we lost Brian. Hang on a second. Hang on just a second. Let me see if I can get Brian back. Give me just a second. Let me go grab him. So this is Aurora with the Central Coast Astronomical Society, and we're going to connect with Brian here in just a second. And it looks like, you know, one of the hard parts about astronomy is usually when you stargaze, you are not in this area. So hang on just a second, and I will get him back because somehow Zoom closed by accident. Hi. Yes. Yes, I know. Look at that. Okay, so we're going to join it. So hi, Ben. You got to say hi to everybody. So there we go. And so, so also what happens sometimes is when you stargaze, you don't have a great internet connection. So that can be kind of a bummer. And so, so sometimes internets aren't so great, but in this case, it looks like it was on our end. So, all right, so how do you see this tonight? So you're going to go outside, and yeah, on that screen is great. And you're going to go outside, and you're going to look southwest, and you don't have a whole lot of time left tonight. So you're going to go outside, look southwest. It's going to be low. You're looking for two dots that are really, really close together, and like as in closer than the diameter of the moon.
I'm back.
They're going to be setting pretty soon. Now you can see this for many more days, like weeks from now. It's just tonight is going to be as close as they possibly can get. Hi, Brian, you're back.
Hello, I'm back.
I'm back.
Yes.
Hello, hello.
All right, so I was kicked out of the meeting.
Yes, so was I. So we're going to go ahead and just wrap things up pretty soon here. We've got a whole bunch of science questions that have come in. So let me see if I can answer some of these. We'll be right back. Thank you for putting that up there. Okay, so the other questions that are coming in, did Galileo see this? No, he did not, but this conjunction did happen during his lifetime. It actually happened after he figured out to point his telescope at the heavens, or up in the sky, because it actually was, this conjunction happened during the daytime last time, so it's really likely that nobody knew about this. So the last time this conjunction happened at night, it actually was 800 years ago. So if you've seen some of the media and they've said, oh, this thing happens every 400 years, every 800 years, every 20 years. To be honest, Jupiter overtakes Saturn every 20 years. So this event happens every 20 years. It's just because the orbits are not in a perfectly flat plane. There's some wobble to them. That this is the year where they line up when you've got one runner overtaking another runner on the inside track. And so it appears that these objects are getting really close. And so they get this close once every 400 years, but if it happens in the daytime, unless you know really where you're going to look, I mean, seeing things, stars, planets, are really hard to do in the daytime. So we weren't able to do that. But last time this happened, it was about 800 years ago. Okay, so other questions, if I can't tell. Okay, so if it's cloudy tonight, don't worry. Check again tomorrow. So these planets are going to be really close again tomorrow. Not as close as they are tonight, but honestly, most people won't be able to tell the difference. So I'm getting a number of people asking about binoculars. Yes, you don't need a monster pair of binoculars if you want to start just stargazing. We have been doing, Central Coast Astronomy has been doing live stargazing every month for free. We just did one 2 nights ago. And so you can join us. You can still look at our website, centralcoastastronomy.org, and view that session. And so that was with astronomer Kent, and he was answering people's questions. It was really, really an awesome way to interact with a real astronomer, and he can answer your questions about constellations and stuff when we're live. But the recording is still up, and so we'll be doing another one in January. And one of the things we recommend is don't buy a telescope. You know, they're really useless unless you know where to point them. The things you should get first is a pair of binoculars. And so definitely help yourself to a pair of binoculars. They don't have to be expensive. Anything you've got is great. If you are looking for a pair of binoculars, you can get a $35 pair, which is great for kids to learn on, from Celestron. They're called Cometrons. Those are great. After you have graduated and you'd really like to do astronomy with a telescope, so you can, it depends on, a lot of people ask us like, well, what do I get? It depends on what you want to look at. It depends what your seeing conditions are. Where are you located? What kind of weather conditions do you normally have? What are you hoping to do? And so there are a lot of different factors in there. Is it going to be used by kids? Is the person wearing glasses? How much eye relief do you need? So there's a lot that goes into that decision. So instead of just running out and buying an expensive telescope that's probably going to wind up as a doorstop or in the garbage can, which happens a lot. I've been a member of the astronomy club for 15 years. You wouldn't believe all the telescopes we have donated. So don't run out and buy one. Please don't. And if it says Costco or comes from Kmart, just give it back. those are, we call those trash scopes. So please don't use a telescope from any of those places. You'll get frustrated and bored and turned off to astronomy, and that's not what we want. We want you to go outside and just get really excited about the night sky. So using a $35 pair of binoculars is fantastic. And if you were part of our stargazing a couple of nights ago, there was a handout that I gave you for what we covered, and on the back is our equipment recommendations. So you can take a look at that, including how you can just use your cell phone to start to do astrophotography. And so that handout was from yesterday as well. Brian, you want to come back on in just a minute?
Yes, and if you could reactivate share for me,
Oh, I am
then
so sorry. Yes, let
I
me do
have a
that.
dark mode view
Yes,
where
look
the
at that. How's
contrast is
that? Are you happy
better.
now? So if you're interested in astronomy and you want to learn more, Sky and Telescope is a good one. There's also Astronomy Magazine. This is my personal favorite chart of all time. And it's the Stargazer's Almanac. It's made by Sky and Telescope. You get it for like $4 or $5 for your latitude and for the current year. But it shows you the progression of the planets throughout the year. So, you know, when you use a cell phone, like an app or something that says, oh, what's up in the night sky, you only get tonight and just this little teeny section of the sky. And you don't see the trends. You don't see really like the overall pattern. You don't get a good feel for what's really going up there. You know, like, can you predict what's going to happen next month? So this will show you, you can see like this is, you read it this way. So it's, so we have January, February, March, June. The nights are the shortest. So this is time from sunset to sunrise. So the nights are shorter, the nights are longer. Here's December way down here. Each one of these lines represents a planet, and you've also got meteor showers on here and so forth. So it's a really good resource. My kids can look at this thing, and they're like 7 years old, 10 years old. They can look at this and they'll say, Mom, okay, Jupiter's transiting at 8, and oh yeah, there's Neptune is going to be setting at 2 a.m. So make sure you get out there if you're gonna, and so they can just tell just in one little glance, they can tell what's going on, which is really cool. So I really highly recommend these. You can get it from Sky and Telescope. It's called the Sky Gazer's Almanac. So if you want to take a screenshot really quick, I'll hold it up. So you can see it. You can take a quick screenshot.
So we have just a couple more
minutes. There you go. Try that. Okay, and so you can take a look at that. And other resources that we have available are on our website. There, we've gotten a lot of questions about, I want to buy something for astronomy. What do I need? You just need yourself and a set of eyeballs. And you can use, if you get a magazine subscription, then in the center is also the current night's star chart, which is here for the current month that you're in. You can also download those for free at skymaps.com, so skymaps.com. And you can get the free monthly what's up in the night sky. And so that's available for both hemispheres as well. Okay, other questions? So thank you
Aurora,
for being a part of this. I really enjoy having the opportunity to share astronomy with you guys and really enjoy having this. So, and it looks like Brian is ready. Are you ready, Brian?
I'm ready.
Okay. All right, let's go take one last look through Brian's telescope. And if you have specific questions for Brian, please use the chat. I know there's a lot going on in chat right now, off topic. Be great if you kept it on topic. Thank you so much. And Brian, why don't you go ahead and show us what you've got?
Yes. Okay, that should be a view now. So this is, by the way, we have just a couple minutes left before these two planets go behind my fence. So I'm going to adjust the gain. As they're getting lower, the turbulence is increasing. So I'm trying to fine tune this. But we can see here that we have Saturn on the bottom and then Jupiter on the top. And we're just able to make out a squiggle for the rings for Saturn. But we are just about out of time, which is why we definitely had a time limit on tonight. This is one of the adventures. But if you are able to go out and you're in California, you'll still be able to see them for a little while longer, as long as you don't have a fence or a mountain in your way. So any other questions for us to bring up while
Let's see.
Here.
Yes, I have a question. People are wondering if refractors or reflectors are better for viewing planets.
Ah,
That's a
so
really
yes,
good
I
question.
find, and what I've always been taught is that refractors can provide a more crisp image for planets. But one of the joys, though, is being able to magnify or the image that you're watching depending on what you want to do. And refractors start to get really heavy if you get a larger aperture telescope, right? So really, I my opinion is that both refractors and reflectors are both wonderful for any kind of astronomy that you want to do. And that's why I think it's becomes more personal preference than actual tried and true, logical answer would say, this is the best.
Nice. There was a question about people were wondering is will you ever see Saturn brighter than Jupiter?
That's a good question. I actually don't know the answer to that. I don't think so. If they're both in the
Saturn
same
is
sky.
so much further out there, like you saw in the
Yes.
program that you shared.
Right. In fact, we could bring that back up. As the planets have now hidden. They are no longer visible. So let me share that picture again.
Okay, go ahead.
Yeah, so just a quick reference in case people hadn't seen this before. Here's Earth, the blue circle. I'll highlight that. And so I'm going to zoom out. And here's the orbit for Jupiter. And then way out here is the orbit for Saturn.
Yeah, it's so much further out there than most people realize, than even I realize. So, yeah, beautiful. Okay. What somebody is wondering about a triple conjunction. Okay, so here, I'll handle that one since you're. Wow, that's a beautiful picture. So so yes, you can have a conjunction like I don't know if you guys were here before. Um, so a conjunction would be two objects that are really close together. And if you like the Scrabble game, you can learn how to spell syzygy, which is what happens when you get three objects, and you could kind of draw a line through them. They don't have to be close together, but they usually are just all in a line is a syzygy. So like for example, during an eclipse, when the Earth, Moon, and Sun are all in alignment, you would have an eclipse. So that would be I'm sorry, you would have a syzygy. So okay, so if the chances that two objects coming close enough together for for people to sit up and take notice, say, "Ooh, what's going on over there?" That would be a conjunction. So usually conjunctions are two objects. You can have triple conjunctions. It's harder and it takes more time for those objects to all three come together. It'd be like waiting for if you're watching runners going around a track. It'd be like waiting for when three runners are really really close together, and like one's passing the other and the slower one, and they all just happen to be in the same area of the track. So, okay, great. Other questions? Did this already happen? So it's happening now, and it's going to continue to happen for another couple of weeks. And so it's interesting when people get excited about meteor showers. They always want to know what exact hour it should be happening. Meteor showers happen for like the entire month. So the Geminids actually is the meteor shower this month that everybody's excited about. And so the best time to view those things, for example, for a meteor shower is when there's no moon. That way you can see the meteors better, right? It's easier to see stars when our sun is not up in the sky. So it's just using your common sense about that sort of thing usually will help. And so one of the questions we get a lot of is the moon up in the sky during the daytime as well as the night? And the answer is yes. It may be washed out so much that you don't notice it, but it is up in the day and night, and where it is changes every night. And so it rises and sets 45 minutes different every single night. So, okay, other questions that are coming in. They want to see your telescope again. Do you want to bring up your picture?
Sure, I'd be
Okay.
happy to.
And so, yes, you can see the conjunction now. If it's cloudy tonight, don't worry. The only place on the planet you cannot see the conjunction is if you live in Antarctica, because it is daylight 24/7 right now. So that's the only place you won't be able to see it. If you're in New York, stargazing is hard, seeing the planets are easy. And so all you have to do is go out there tomorrow night right at sunset, and you're going to look southwest. So get to the tallest building that you can, look southwest, or look somewhere where you have some horizon, because they're going to be low, and you'll be able to have about an hour of viewing before they dip below the horizon. So yes, great questions. Okay. Can you see it? Yes, you can see it from anywhere on the planet, anywhere except when the sun doesn't go away. So this is a really great one. It's going to be up for another couple of weeks. So if the weather didn't cooperate tonight, don't worry. If you don't feel like going out for a drive to finding a little patch of good weather, no problem. You can totally see it in the next within the next couple of weeks. So just go out tomorrow night and the next night, and so you'll get your chance over and over. You don't need a telescope. You don't even need binoculars. You just need to go outside and take a look. Okay. Brian, tell us real quick about your telescope, and then we'll wrap things up for tonight.
You betcha. So this is an Orion 120 ST refractor telescope, and I have a ZWO ASI 2600 camera connected straight where the eyepiece would normally go. And this telescope can be used for visual astronomy too. You just put a camera where the eyepiece will go, or if you want visual, you put an eyepiece right here. And then I also have a finder scope with a ZWO ASI 120 camera. That one's black and white, used for finding. The mount that I'm using is a Celestron Advanced AVX. And I'm using a hand controller to talk to it, but I can also use a computer to do the pointing for me. And then, by the way, the program that I was using for everything tonight is called SharpCap. And it's designed to work with video astronomy cameras like these. But just a reminder, if you're getting started in astronomy, or astrophotography, I should say, you do not have to go out and buy a bunch of equipment like this. You can start with just your SLR camera, or frankly, even your cell phone now. Cell phones are so advanced, you can point them at some of the brighter objects, and the built-in little computer processor will process that image. So you can start astrophotography right now just with your cell phone if you wanted to.
Nice. And yes, so somebody was asking, why is the moon visible but not the stars at night? During the daytime. The moon is really, really bright. It's super bright. In fact, if you try to look at a full moon through a telescope, like, well, any telescope, or even with a pair of binoculars, the first thing you'll do is go like this, ow! Because it's so bright. Most astronomers have to put on a set of sunglasses, more or less, to cut down on the light because it is so bright. Same thing if you look at Venus through a telescope, it's really bright. So, anyway, so that's why we can see it day and night. Okay, so yes, we're going to go ahead and wrap things up. We only meant to be on for 10 to 20 minutes. It's been 50. You can rewind this and watch more. You can get my recommendations for different types of resources, where to look, how to share this with others. I invite you to look at the astronomy, the stargazing we did 2 nights ago. So you can just watch that and join myself and Brian and Kent Wallace, who is one of the world's leading experts on planetary nebula. And so you can watch that and really just be part of our stargazing event that we were doing. So go to www.centralcoastastronomy.org, which is the link right here at the bottom, and you'll be able to view that. It's totally free. We love just sharing the skies with you. The next one we'll be doing is going to be in January. Now, if you have specific questions that didn't get answered, you can always reach us through our website, centralcoastastronomy.org. You're welcome to ask any and all questions about astronomy that you would like. There is one more resource I wanted to share. If you have not found the podcast called Astronomy Cast by Fraser Kane and Dr. Pamela Gay, I would encourage you to check that out as well. It's just look up Astronomy Cast. She's got over 500 episodes. I think they're almost at 600 episodes right now, and they've been going for about 15 years. So there's a ton of resources that they share, and they don't charge for it, and they don't get paid for making it. They just love astronomy and want to get the information out there. Fraser also runs Universe Today, which publishes astronomy articles that you probably would really enjoy, especially if you're still watching me. Brian, any other last closing remarks that you want to share? Oh, wow. Look at Brian. He is busy. You guys want to watch him for a second? All right. So what are you doing there, Brian? What is that?
So
thing?
I just, I figured, yeah, it is actually quite a big rock. We know it and love it as the moon. So I just thought, hey, while I was out here, always a good time to do some astrophotography
Yeah,
of the
why is it
moon.
green? People are
So
really wondering about the cheese thing right now.
that's a good thing. That's a good question. Yeah, that and part of that is because I need to color balance my camera.
Yeah, so it's not really that color. It's
No,
fine.
it's not
Don't
really
worry
this
about
color.
it.
No, and that's why, before we fine tune the equipment for the kind of objects that we're going to show live. For instance, if I was doing some deep space objects, then I have different filters that I would have put in place to draw out what we'd want to show for that. So for the moon, have a little bit of work to do before, this would be super
Nice.
presentable. But I just thought I'd
Awesome.
see how it
And
looks.
if you have any suggestions for things that you would like to see for the next stargazing event that we do, let us know. We've been focusing on about 4 or 5 constellations and showing you things you can see with binoculars that most people don't even realize that they're there. So if you have something specific that you're interested in knowing about, just let us know so we can take that into account when we go ahead and put together our next stargazing show. So, all right, Brian, you ready to sign off? Oh, here, it looks like he's got a really nice image. So, Brian, there you go. Do you want to talk about the Terminator real quick, and that'll be the last thing we cover?
Sure. I know that's the thing is we could just keep on
I
talking.
know,
We get
we
in
can
on
talk all night.
astronomy. So the moon goes through phases throughout each month, right from new moon where there's nothing to a full moon where it's completely illuminated. And the terminator is that boundary between the portion that's lit and then dark. And believe it or not, when the moon is full is really one of the worst times to try to observe because it's just so darn bright. As the terminator, or that difference boundary, I should say, the boundary between light and dark, travels across the moon throughout the month, it casts wonderful shadows and actually starts to highlight different features, especially the craters. And so right now, I checked yesterday, we're about 40% with the moon. This is a waxing crescent right now, I do believe. And so this is a great time to observe the moon. And remember, binoculars are wonderful to point up at the moon too. And
Nice.
then just, I guess I'll say again, the colors are like this because I need to white balance the camera.
Yes, everybody's wondering if it's a green moon or a blue moon right now. So if you've ever taken a picture or had your webcam and you haven't done white balance on, and you're like green or like red, that's what's going on. So he was optimized for looking at the planets. One of the questions, did you want to answer real quick? I meant to ask this one before. They're asking about the angle that the rings that Saturn is making,
Yes,
and yeah, and how it changes.
absolutely. Oh, I closed out NASA eyes, but
Oh, that's okay.
so
That's okay. Do you want to just
so
talk about it?
Saturn
I'll have
Saturn
a pitch. I'll get a picture of Saturn's
Okay,
rings here
sounds
for you.
good. Yeah, so Saturn is actually at an incline in its orbit around the sun. And so depending on where Saturn is in its orbit and also where we are in our perspective to Saturn in our orbit throughout the year, it actually shows us a different angle depending on our alignment. So Saturn's ring can go everywhere from edge on, where we barely see anything at all, to a very wonderful tilt. And so this chart that you see here, notice that 2020 is down in the third row down from the top. And so then it's already going to be changing. Next year will still be quite favorable. For instance, that shows August. But notice by September of 2025, we'll be edge on again. So I'm really excited that this year was such an one of the few good things that seems like that happened this year was so many more people had the opportunity to get into astronomy. And so Jupiter and Saturn seems like they coordinated this not only for the conjunction, but then Saturn showing us a great perspective of the rings. As
Yes.
the first time each of you see Saturn in a telescope with your own eyes and can see the ring, is like, yes, you really can see it.
Yes.
It's
And it's one of those
fun.
objects that we love to show people. The Saturn and the Moon are the two, and then Jupiter with the
Yes.
moons around it. As soon as people see it, their jaw drops to the floor and like, whoa, that's not real. Like somebody's got. I remember looking around at the other end of the telescope, thinking somebody put a postcard there or a picture of Saturn. That's not really what I'm seeing. But it was, and it was through a small telescope too. And I'm like, I can see the rings and space between the rings. It was so cool. Like you don't forget that moment. All right,
No, definitely not.
Brian. Oh, you guys want to see a blue moon? Here we go. He's doing some color balance.
Yeah.
There we go.
So I fixed the moon. Fear not, the moon is okay now. So, but by the way, this is not, if you see pictures come up of a blue moon on Facebook, that's not what a blue moon is. Blue moon is just the name for when we have two full moons in the same month. And so that's what a blue moon is. It has actually nothing to do with the color. But so here you go. This is a little more representative. By the way, um, yeah, oh, I guess you know what? We'll go off talking about reflectivity of the surface of the moon. I
We
think we'll
could talk
better,
about that next
Abito.
time. Well, we
Yeah,
had some questions
we'll
about Earth shine and so forth, but why don't we cover
yes,
that next time?
sounds good. All right, it's getting
Yeah.
cold out here anyway, so I think that's
There's a lot that we can cover. So, if I was going to sum up everything that we talked about tonight into 2 sentences, probably more, I would say the conjunction is up now. It'll be continued to be up for the next couple of weeks. Go out right at sunset. Look southwest for about an hour. You'll see it before it dips down below the horizon. It's an optical illusion. You're seeing Jupiter catching up with Saturn, and then it's going to pass it, and you'll see two bright dots, and they won't overlap and become this super bright star. They're not going to smack into each other. It's just you're seeing one overtake the other. And that's what a conjunction is when you have two objects. You could have a conjunction between the moon and Saturn. You could have it between any objects that are out there that are of interest. And so, yes, and so my name is Aurora with Central Coast Astronomy, and this is Brian. He is in his backyard with his telescope. He got his gear out just for you guys, so he could show you in case you wanted to see it through a telescope. And he has a really interesting image of the moon right now, so I'll show you that while I'm finishing up. And if you would like any of the resources that I talked about, please just go back through and take a look. We talked about the Sky and Telescope magazine, the Sky Gazer's Almanac, the skymaps.com. We talked about a couple of podcasts, as well as how to do stargazing online, virtually, and just make it easy for you to do real astronomy. Our whole goal is just to get you excited about the night sky, so you want to go outside, look up, and know what you're looking at, and so without having any fancy equipment. If you have a pair of binoculars, I recommend 10 by 50s. If you have kids, 7 by 50s. You can get a $35 pair from Celestron. These are from Orion. They're probably about oh, no, these are actually the Cometrons. This is the cheap pair. Don't they look good? The one behind me is 25 by 100. It's like looking through a 4 or 5 inch telescope, only with 2 eyes, and I absolutely love this thing. This is an uber work. And this is new for me, and so I'm really enjoying using it, and I can see amazing things with it. And it's light. It's only like 10 or 12 pounds. You have to have a tripod with it because it's heavy. So if you have any other questions, let us know. This is Aurora and Brian. Brian, let me go ahead and flip over to you real quick. We're going to be signing off. We're going to go finish looking outside. And Brian, thank you so much for setting up your equipment.
Thank you.
I really
This is
appreciate it. That was very kind of you
great
for
time.
tonight.
Yes, I really enjoyed sharing all this with everyone. So I'm really glad we got this opportunity. So thank you everyone for joining us.
Awesome.
And
Thank you, everyone. We had, gosh, I want to say a couple of thousand people on at one time and about 35,000 people just joining us, popping in and out. So thank you all just for your interest in astronomy. So get out there, go enjoy it, and I will see you at the next stargazing event. You can join us, you can follow us, like our YouTube channel, share Central Coast Astronomy with your friends, and let them know that they're out there. We can help you guys do astronomy. So go to centralcoastastronomy.org. You can like this video, you can follow us, and we'll see you next time. Take care, everybody. Bye-bye.
bye, everyone.